Hey y'all, it's Ken's Ken Ken's Chem vlog. Ken's Chem vlogs. This is the last of the notes. It's basically memorization. I think it won't be that bad. But yeah, this is the last part before the test, and I don't think she gave us enough time. Like, she's like, oh yeah, you have to memorize all of this shit. And then, by the way, your test is in like 3 days. So yeah, so just test is 30 questions. Since there's 5 sections, there's gonna be 6 questions per section, which isn't that bad, honestly. So okay, let's go over what is molecular geometry and what is the purpose of knowing this. Okay, so it's literally a 3D structure of a molecular compound, like H2O. This is H, right? It would just be like, how would you put that in 3D in our regular life, right? Honestly, it would look like, let's see if I have a photo. This, right? That's what it would look like in real life, right? It's 3D, you can hold it, right? And so that's what we're just understanding, right? This is 2D, we're trying to look at 3D, right? So what's the purpose? It determines properties like the polarity, solubility, conductivity, melting point, all that kind of things. And it can also be used to predict biological activity, like, do drugs work together with certain things? How does it work with certain people? It's just, when someone's creating a drug, you need to know how it works with all types of people, old people, young people, people with certain diseases. And that's why when you see in commercials, it's like, do not take if you are suffering from this, or you also take this, or you, something like that, you know, because it's, the 3D structure helps show you what can go with it and what cannot, right? So the strength of multiple bonds, I think this is really easy. Just think triple bonds are really strong and they're the shortest. And single bonds are the longest and the weakest. Single bonds ain't going to the gym. Triple bonds getting those, popping on those steroids, geophil, am I right? Anyways, so single bonds are the longest and the weakest. And you kind of think of this like, it's weak because let's say you have a stick, right? It's a stick off a tree branch, right? It's a single tree branch, right? And it's longest and it's weakest because if you try to snap it, it's going to break, right? But let's say you get 2 smaller tree branches and you put them together and you try to break it. It's going to be much harder to break, right? You're going to have to like put more effort into that. And let's say you have 3 really small tree branches, right? And you try to break that. It's super hard to break 3, right? But it's much easier to break 1, right? So single bonds are longer, and the more bonds there are, the shorter the length it becomes. So just think of it as like a branch, right? A single branch is going to be weaker, and it's going to be longer, and it's easier, right? Okay. VSEPR, some people say VSPR, but I think that you might forget the E. VSEPR stands for valence shell electron pair repulsion. So it's just a fancy way of saying like electrons repel. You know how they say opposites attract, right? Same thing here. Opposites attract, and things that are similar, things that are the same repel. So, or you call it repulsion, right? Electrons want to be as far away from each other as possible, right? These two are away from each other, right? Oops, okay. And we can predict things like that with a shape. So that's really all you need to know about that. Okay, so this is what some people get confused on. Types of electron domains. Domains are just things that surround the central atom, right? Or center, right? Some things like O2 or H2, they don't have central atoms, so that's non-applicable. DNE does not exist, right? Just, there's nothing surrounding a central atom because there's no center. But anyways, electron domains are just things around it, such as, like, this is an electron domain, this is an electron domain. These are all, like, any letter is an electron domain, right? This, and this are electron domains. This, and this, because it surrounds the center, right? This, and this. Lone pairs are also domains. So if there was 2 right here, this would also be 1 domain, right? I don't really think you need to know. Lone pairs are just non-bonding electrons because they're not bonding to anything, right? They're not bonding to anything. You're just like alone. They're alone, right? They can't bond with anyone because they're introverts, you know? Story of my life, just kidding. They take up more space because, more negativity in the system. Anyways, I don't think you need to know that part, this part. So, steps for determining a molecular shape. Draw the correct Lewis structure. You gotta do that first. I'm not gonna explain that because you should know it. Yeah, I'm sorry. Just go to one of my other videos, like and subscribe. You know what I'm saying? Then count the number of electron pairs and around the center atom. This includes bonding pairs and lone pairs, right? Triple and double bonds count as 1 pair. So triple is not 3, it's 1. It's just one thing, right? That's one thing. That's one thing, okay? That's one thing, okay? They're not multiple things. It's just pairs are 1, okay? Just think of that. This should be pretty easy. Dashed line means behind. Bolded wedge is in front. And when you're kind of thinking of like, how do I write this? Especially if you're on the test, even though it's multiple choice. If you're thinking of how to write it, Miss Sancho said, it doesn't really matter if all of these dimensions around each other are the same, right? It just, as long as you have the dot, the dashed, or the bolded wedges. So, how to draw the molecular geometry? We'll just get through that right now. So, we need to memorize this stuff. 6, you don't really need to memorize. The test is mainly focused on names and how it's correlated to its degrees. So, by the way, 2 models side by side, like H and O, are just linear, right? But okay, so we're going to go down. So we're talking about number of electron domains. If there's 2, then it's linear, right? There's one domain, 2 domain, right? And if we write it like that, the degree is the space between like the bonds, right? And that's 180, right? Obviously, because it's a straight line. Just think that, right? And if you did another 180, it looks like a circle, right? And we know circle is 360. So that's an easy way to think about it. But then we get into 3 domains. So as you can see, I'll just do this. Yeah. Okay, I guess that's not working. X, that's 3 electron domains, right? And each side is 120 degrees, if you do it on all sides, it makes a circle, right? And then here, there's also 3 because a lone pair counts as a domain. It's a thing, right? And when we're looking at one and we're saying, is it bent? Is it trigonal planar? Is it angular? No one says angular, by the way, just say bent, you know what I'm saying? We just cover the electrons. So pretend this is my thumb, right? I'm just going to cover this on the paper. Actually, no, that's not good. Okay, there. Pretend this red thing's my thumb. I'm just going to cover that, right? And whatever the shape looks like, I'm going to always cover the lone pair. And whatever the shape looks like is what we can correlate it to. So I'm covering the pair, and it looks bent, right? It's kind of bent, right? Same for like this one down here. I'm covering the electrons, and it kind of looks like a triangle, right? So that's just a way of thinking about it. Same here. Cover these, and it's bent, right? Cover these, and it's T-shaped. Cover these, and on this side, and it's linear, right? Cover these. Oh, cover this, and it looks like a seesaw horse. We'll get to that. But yeah, so basically, you see the degrees here is 120, 120, and 120. It's basically 120 for this one, even though it says less than, she just wants you to remember 120. Okay, so now we're getting into actual 3D stuff, right? So, the tetrahedral is when there's 4 domains, right? As you can see, it's pretty common, I think, from what the homeworks are and the IPs were. Trigonal pyramid and bent angular, these are lone pairs as well. you need to know this one's 109 degrees everywhere, no matter where you are. This one's less than 109 degrees everywhere. Hold on 1 second. Mom, I'm doing a video, so go away. Sorry, children. I did not mean for that to happen. It's fine. I love my mom. Just, you know. Okay, this one's less than 109, but you don't really need to know that. You just need to know 109.5. Trigonal bipyramid. For these parts, it's 120, 120, 120, right? But these parts are 90, all right? Okay? So, so keep moving on. Seesaw or sawhorse. Most people just use seesaw. She's going to probably go by that on the test. You see these 120 angles and the less than 90 angles. And then these are probably 90 as well. 90 here. Everything is 90 here. If it shows only one. Everything is 180 here, right? Oh, also, if you can see, we're not finding the distances between the pairs, lone pairs, and the other bonds. It's just between bond. Okay, next thing, you don't really have to remember that. This is just an example, right? First step, draw the Lewis structure. First, you want to count the electrons, make sure you count them right, and make sure you keep track of them, right? This, as we can see, I'm going to hide this. We put them all around, making sure we are keeping track for electrons. Hydrogen always gets 2, we know that, right? The center always gets 8, right? From the octet rule. And then we put the rest around the CL. Okay? And the electronegativity would go this way. If we're just going to write that, just letting you know. That's just from a different unit, different section, so I was pulling that in out of my head, you know. I'm unorganized like that. As you can see, there's 4 domains. I counted 1, 2, 3, 4. So if we look up here, and this is going to have to be in your head for the test. I go to this one, right? How many lone pairs are there? Heck, I don't see any. And you might say, oh, I see 3 up here. That's 3 lone pairs. No, it has to be on the center for us to count them. So it's tetrahedral, right? Simple and easy. There's 4 electron domains. No lone pairs are on the central atom. Oh my god, what did I just say? I think that just, you know that Ariana Grande meme where she's like, I want to see what you just wrote on paper. That's that kind of moment, you know what I'm saying? I'm rolling around, like, saying random shit out of my head, and it might be confusing you. Rolling Ray type shit, you know what I'm saying? Okay. So, yeah, as you can see here, beryllium hydride, there's Be and H2. We drew it first in 2D, and then we wrote it like this, right? And it's 180 degrees on one side. And then you know that's linear, right? Linear line. For this one, there's boron trichloride, so there's 3 chlorine atoms, and there's 3 domains, right? And we know that there's going to be 120 degrees in between them if we look over here, right? And then for these 2, we don't do any of like the wedges or the dotted lines because it's only 2 or 3 domains. But once we get into 4, 5, and 6, that's where we have to draw them. Okay, let me go into my notes real quick. I'm sorry, y'all, if this is confusing. Leave a comment, like, and subscribe because I don't give a poop. I can't say bad words anymore because Miss Hanshaw, if you're watching this, I am so sorry, you know. Actually, I'm not sorry because I'm not saying any bad words. So, the common degrees, like, for linear, it's usually 180 degrees, right? And also for the number of domains 2, it's usually 180 degrees. Number of domains is 3, it's usually 120. Number 4, it's usually 109.5. It's always going to be 109.5 if you're going off this list, right? Everything here is 109.5, but this one is less than, and this one's also less than, but you gotta think 109.5. And then for number 5, 6, we don't give a shit. Y'all, erase that moment I just said in my history, we don't care about 6. You know, I'm doing the Santa Claus right now. I swear, I didn't mean it. Don't take off my grade. Anyways, 5 is 120 and 90. And you can actually have 2 degrees here. There can be multiple. 120 obviously is the biggest degree, and there's 90. So 90 here and 90 here, and then 120 in between here. Yeah, and then 2 atoms together is always linear. Yeah, that's really all I can say. Okay, bye. I probably have this sent to y'all, but if you don't, leave a comment and I might look it up, but I probably won't because I don't know how to work YouTube. Okay, bye. I have to eat now.